Welcome back to my channel, Data Carrot. Today we are deep diving into the world of query optimization. If you have ever wondered how massive platforms like Flipkart or PhonePe handle millions of transactions without getting slower, the answer lies in the three powerful strategies, that is indexing, partitioning, and clustering. In this video, we aren't just going to define these terms. We are going to look at the business impact and the technicality behind them. We'll bridge the gap between logic and code, looking at real world cases like UPI and the balanced tree structures that power modern databases. Whether you're preparing for a data interview or building something of your own, this will guide you on how to go beyond the basics. So let's get started. Imagine a database without an index is like going into a library where books are just thrown onto the shelves in the order they are bought. To find one book, a librarian has to walk through every single aisle. That is what we call a full table scan. It is a silent killer. It destroys our performance because our table may grow from 1000 records to 1 crore records over the time. And the time required to complete the query will grow linearly. An index is a digital catalog. It is a separate small data structure that stores a specific keyword and a pointer or address. Instead of reading the whole book, you look at the index, find the page number, and jump straight to the information you need. Most of the databases use a structure called B tree or a balance tree to manage these indexes. Think of it like navigating a street map of India to find one specific house in Bangalore. The root node acts as the first filter. It will filter out if the house is in north or south of India. The branches will narrow it further down, go to Karnataka, then to Bangalore. The leaf nodes are the final destination, which will point us to the main street, the house number. Mathematically, this turns out our O of n search into O of log n search. In plain English, it is like finding one specific record in a 1 crore row table that will take only about 20 jump or operations instead of the linear 1 crore. Let's try to apply this to Flipkart. When a user types red Nike shoes, ideally the normal query which runs has to scan the database for the entire 50 crore products. Now looking at this code of indexing, a standard B-tree index here on the product name creates a sorted list of the names. Now searching for Nike is like a binary search rather than a complete scan. Just below it is a composite index example where we use two of the columns to create an index. For example, here we use a combination of category and brand. That will be shoes, that is the category, and brand, that is Nike. Now let's talk about partitioning. If indexing is a surgeon's scalpel used for precise operations, partitioning is like a master of organization. Think of it as a massive file cabinet. If you throw around 30 years of tax records into a single drawer, searching for an example of a record belonging to 2024 is kind of impossible. Now, partitioning gives every year a drawer of its own. The magic here is the partition pruning. If your SQL query specifies where year is equal to 2024, the database engine prunes or ignores the other years completely. It never even touches the data, which saves a lot of CPU and memory for every query of ours. For an app like PhonePe, transaction grows by millions of records every single day. We can't keep all that in a single table. The partitioning code here gives us an idea about how partitioning is used in real life applications. We define the structure and use partition by range of transaction date. This tells the database that it is going to give us specific rules on how to split the actual data. We create a separate table for each month, like transaction for January 2026. When the data gets old, we don't use a normal delete command to delete the old data. We can simply drop the partitions. Dropping a partition is instant, whereas deleting the millions of records might take hours and which can also lock our database. Finally, we get into clustering. This is different because it actually physically reorders the rows on the disk. Imagine a store like Big Bazaar. You don't put toothbrush in aisle 1 and toothpaste in aisle 10. You put them together because customers buy them together. In a database, if the rows you need are physically next to each other, the disk reader doesn't have to jump around randomly. It just performs a sequential sweep, which is the fastest way you can read large amounts of data in a small time. Let's see how clustering happens in action. Suppose we have a table called sales, and let's say you frequently pull reports for all sales in Bangalore. Looking at the code here, we create an index on the column city because before clustering, we must have an index first to act as a map. Then we cluster the sales table using indexed column, that is city in our case. This command tells the database to physically sort the sales table based on the city column. But this is a one-time operation. As new sales come in, they aren't automatically clustered. We have to rerun the command periodically to maintain the physical order. To wrap it up, here is a summary of all our three operations. Indexing is basically used for point queries, finding that one specific user or product. It is comparatively heavier as compared to the other optimization techniques. Partitioning is used for time series or playing around with big data, managing history and pruning operations. Clustering is used for ranged queries, grabbing all the records in a single region or a department all at once. Like everything, all the three techniques have their trade-offs. For example, too many indexes slow your query down very much because the balance tree must be recalculated every time. Storage is also a factor. Indexes take up extra spaces, but clustering use zero extra space. It just reorders the data which is already present. And we come to an end. So these are the techniques that are generally used for optimization. And by using all these three techniques, standalone or in combination, you can convert queries which take minutes for completion to milliseconds. If you have any questions or want to see a deep dive into other problems like sharding versus replication, let me know in the comments. Don't forget to like, share, and subscribe for more these kind of videos. See you in the next one.